So this section you guys are gonna probably find difficult, so just bear with me, give me some time. This here's a chart. I I don't really use this chart. Let me show you over here what I would like you to do. Um, so we know that everything in the first quadrant, everything's positive, right? This angle right here, let me just call this the reference angle. If I were to put this angle over here, what would I do to find this angle right here? Okay, so if it's in the second, if it's in degrees, use 180. If it's in radians, use pi. We know that all the way across is 180 or pi. So if I only want to find this angle, I'm going to take 180 and subtract the reference angle. Or I'm going to take pi and subtract the reference angle. Now, what if my angle's over here? Let me keep my colors. If I want to find this angle, and this is still my reference angle, this time I'm going to take 180 and add pi. If you're in the third quadrant, you're going to take 180 plus the reference angle, or pi plus the reference angle. So notice if you're in the second or the third quadrant, you're always going to use 180 or pi. If you're in the first, that's going to just be your answer. And finally, if you're in the fourth, this is 360 or 2 pi. So think about if we go all the way around, that's 2 pi. But if I want to take this out, I'm going to take 360 minus my reference, or 2 pi minus my reference. So that's maybe what I kind of have just as a reference. And then this is going to make a little bit better sense for once we do example 13. Now, I found that I did not have enough room. So if you still have some room up here, I'm going to do, maybe I'll do letter A up here, letter B, and letter C, just so there's plenty of room. All right. So first of all, this wants two angles in which cosine equals positive 1/3. This is in degrees, so we're going to put everything into degrees. Now think about, where is cosine positive at? The first, all students take calc, and the fourth. So our first goal is to find this reference angle, and you're going to need your calculators. So if you don't have your calculator out, go ahead and pause the video, get your calculator. All right, so the next thing we need to do is figure out what this angle is. What angle gives us 1/3? Because there is no special triangle that uses 1 and 3 in it, so we have to do our calculator. Now, if I want to get theta by itself, what do I do to both sides to get rid of cosine? I'm going to take cosine inverse of both sides, because that cancels out, we're left with theta. Type cosine inverse of 1/3 on your calculator. Now you might want to check, since this wants degrees, check your mode and make sure it's in degrees. So you're telling your calculator you want degrees. I get 70.5 degrees. Does it make sense that this angle right here is 70.5? Because it's a first quadrant angle, right? Now, what it's also telling you is that's what this angle right here is. So how do I find my fourth quadrant angle over here, that there's a reference angle of 70.5? That's when you go over here. In the fourth, I'm going to take 360 minus the reference angle. And my second angle is 289. I don't know if that's 3 sig figs, so I'm just gonna leave it like that. Okay? So those are the two angles that give me a cosine of these two angles will be a positive 1/3. So what that's telling you, if you take cosine of 70.5, it's going to be 0.333 repeating. If you take cosine of 289 degrees, it's going to be 1/3. Now, you probably need more accuracy, but that's pretty close. All right. So this is always when we're looking for theta, we're looking for the angles. All right, let's look at letter B. Now, where is sine positive? Positive 3/4. So it's in the first, and sine is also in the second because all students, sine is in the second. 3, 4, and we don't really even need to set up the triangles, but I think you need to see where that second one is, and this just gives you a visual, okay? So theta is sine inverse. Anytime you're looking for an angle measurement, you have to do the inverse on your calculator. And that's just second sine. Let me do it on my calculator. So I get theta to be 48.6 degrees. So this is my first quadrant angle. So that would be the reference angle over here, 48.6. This angle is the same as this angle. But now to get my second quadrant angle, I want to go from here over to here. So I'm going to take 180 and subtract off that reference angle to get 131 degrees. Okay. So to me, finding this with your calculator is not hard. It's understanding how to find that second, the two angles, the second one. So I think drawing the two angles where you can see them helps you visualize that you need to take the 180 minus to find this one. Or all the way around up here was 360 minus that 70 to get the 289. All right, finally we have tangent. So tangent is in the first and the third. So theta equals tan inverse of 2, which is 63.4 degrees. So that's this angle, the first quadrant angle, and it's also this angle down here. So what do we do when it's in the third quadrant? I'm going to take 180 plus that reference angle. Which is 243.4. Now, I think, in my opinion, the positives, it makes a lot more sense doing the positives when these are positive, and it also makes sense when we're doing degrees. So this hopefully wasn't too bad. The next example is in radians, and it's where it's negative, so just be patient. So notice this interval is between 0 and 2 pi. So I'm going to draw this. If all students take calc is where everything is positive, this says sine is negative 0.4. Where is sine negative if it's positive in the first and the second? It's negative in the third and the fourth. So the first thing we do is take sine inverse of negative 0.4. Now, one thing that we'll need to talk about is the restricted domain, and I'll get to that later. But what I want you to understand, everything that's positive is the reference angle always goes right here in your calculator. If sine is positive, cosine positive, tangent positive. If these numbers are negative, cosine is going to be put over here, sine is going to be put on here, and tangent's going to be put here. This is going to go backwards, so it's going to give us a negative value. So you might want to maybe put that right up above the example, just this little reference here. Because notice when you do sine inverse of negative 0.4, a second here, oops, helps if I put it in correctly, I get negative 23.578, blah, blah, blah. All right. What that's telling me is this angle here is 23.5. Now, the negative just means it's going backwards into the fourth because that's where we put sine. So our reference angle is always positive 23. Reference angles are always positive. So if I want between 0 and 2 pi, here's my 2 pi. If I go, both the reference angles are always the same, 23.5. How am I going to find this angle? This is pi plus my reference angle. So you literally just take your pi button and add 23.5 to get your first answer of, oh, whoa. I'm using my stupid regular calculator. We got to be in terms of radians, guys. Sorry, let me get my real calculator. So that's the degrees. Notice I haven't put degrees and I said it's in radians. So make sure you go to your mode, make sure it's put it back into radians, then do sine inverse of negative 0.4 because your answer needs to be in radians. I'm sorry, I got distracted. So everything is, I was like, that's too big to be a radian value. All right, so this is, everything else is the same. It's just we have to use our radian value. So this was in radians, negative 0.4115. So our reference angle is a positive. With reference angles, you just make this positive. It's the same thing. So this is degrees. We're going to use radians instead. Pi plus my reference angle is 2.73. Now, we also need our fourth quadrant. So I'm going to take 2 pi and take away my reference angle. 2 pi minus the reference angle. And I get 5.87. Oh, you know, my calculator had the negative up here. This one, just go ahead and shoot me. Which I should have seen because pi is 3.14. So when I add my 4.4115, should be 3.55. All right, sorry about that. So this should be more than pi, and this is just a little under 2 pi. All right, let's try B. And I promise to have everything in radians now. Okay, cosine is negative in the second and third because it's positive in the first and fourth. So when we take cosine of negative 2/3, cosine inverse to find the angle, I get 0.785. Nope, just a minute. I didn't get the second in. Negative 2/3. I get this angle right here, because remember cosine when it's negative gets put in the second. This is 2.30. Okay? That's actually my first answer because that's between 0 and 2 pi. That's the easy one. Now, here's my question. I need to find this reference angle here. So what would I do to find my reference angle? If this is pi and this is 2.3, I'm going to take pi minus my reference angle. This angle here is 0.841. That means this angle here is 0.841. So I need to now take pi plus the reference angle, not this angle, because that's the full angle there, and to get 3.98. So in my opinion, it's extra confusing being negative and extra confusing being in radians. So just give yourself some time. We'll talk more about this next week. Or this week, depending on when you're looking at this. All right, finally, tangent. Tangent's positive in the first and the third, so it's negative in the second and fourth. Okay, so first I'm going to find tangent inverse of negative 1/3. Now remember, tangent negative is going backwards into the fourth, so when you do tan inverse, negative 1/3. This angle going backwards is negative 0.321. I'm going to go a little bit further, 175. That means my reference angle is positive. When you're turning it into a reference angle, you've got to make it positive. The negative just means it's going backwards into the fourth. But it doesn't want us to have any negatives. The interval's asking us to start at 0 and go this way around. All right? So if this is my reference angle, first of all, this reference angle is right here, 0.3217. How do I find this angle? I'm going to take pi and subtract my reference angle. So my first angle I need is 2.82 if you round correctly. All right. Now I need to find this angle. This is the one going backwards. I need to find it going frontwards. One thing you could do, if this makes sense, since this is negative going this way, you could always just add 2 pi to this negative value. Or you're going to take 2 pi minus the reference angle. And let me plug this in my calculator. To get my second angle of 5.96. Okay. So in my opinion, this example is probably the hardest one we've done so far, but it really gives you a better understanding when you get it. I think that's the end of F. And the good news is G is actually pretty easy. First of all, The big thing is, if we are gonna write an equation of a line, we need to know the slope. And if we're talking about trig functions, we're just using tangent, because remember earlier we said tangent is y over x, which is our slope. That's all I really want you to get out of this page. We're not going to talk about the proofs. All right, so right here, it says write the equation of the line. First of all, this is super nice because it gives me my y-intercept of b. And the slope is really the change in y over the change in x. That's just tangent of pi over 6. So if this is pi over 6, that's 30 degrees. So across from 30 is 1, 2, square root of 3. The line is going up, so it's positive. So my slope is tangent y over x. So y equals m x plus b. Done. So if you can just understand, if there's an angle measurement given and they want an equation of the line, you just need to take tangent of that angle. All right. Finally, find in radians the measure of theta. If we look at the equation of this line, this is telling me the slope is -1/2. That means tangent of that angle is -1/2. So to find the angle, I take tan, I don't know why I wrote that, because that negative goes here. I find tan inverse of this to find what the angle is. So plug that into your calculator. Tan inverse of -1/2, -0.463, really 4. All right. Now, notice this is my angle that I'm looking for. That's how they have theta. So my reference angle right here is the positive 0.464. So I'm just going to take pi minus this value because it's in radians. Pi minus that. So theta here is 2.68.